Hello everyone, welcome back. Here is vanAmsen with another live coding session. So today we have a really interesting problem from LeetCode Daily Challenges, a mark as medium, that revolves around ants walking on a plank. So let's dive right in. Imagine a wooden plank of length and units, and there are ants walking on this plank. And each ant can move either to the left or the right at speed of 1 unit per second. Now, when two ants meet, they don't collide and stop. Instead, they just reverse their direction. And the twist here is that when an ant reaches the end of the plank, it falls off immediately. So the challenge, given the length of plank and the position of ants moving left and those moving right, we need to find out the moment when the last ant fall off the plank. So let's say our plank is of length 4 units as in this example illustrated on the left, and we have two ants at position 4, 3 moving to left. So yeah, let me mark those 4, 3 to the left. So those ants, and at 0, 1 moving to the right. And if we visualize this after 4 seconds, so yeah, here they are moving, switching directions, and moving forward, and finally falling off. So it takes 4 seconds, so output is 4 seconds. So what could be possible logic? So one approach could be simulation, but it might be not so efficient with running complexity of O(n) squared. And yeah, so we will try to solve it using two approaches. So all right, let's dive into our first approach. So at glance, the problem might seem really daunting due to interaction between each ant, but a beautiful simplification awaits us. So let's think about it. When ants moving to the left means though moving to the right, they basically switch direction. But if you visualize this, it's just as if they continue walking straight through each other. Yeah. So knowing this, we can simplify our problem. Yes, so for ants moving to the left, the time it takes to fall off its direction is exactly proportional to their current position on the plank. Why? Because they just heading straight to the 0 position, and ant at position 3 will take 3 seconds to fall off, and so on. So for ants moving to the right, the time is a bit different. So it's the distance they have to cover to reach the end of the plank. So if our plank is, for example, 10 units long, and we have an ant at position 2, it will take 10 minus 2. So 8 seconds for it to fall, but basically logic is exactly the same, but we need to reverse direction. So let's transform this to the code. So first implementation will be really handy, especially in Python. So return max left default dig 0 and minus minimum right and default. So this is the maximum for left and reverse, so length of the plank minus minimum position of ants moving right. So yeah, let's run for sample test case. We previously mentioned 4 seconds, all good. Now let's submit it for unsync test cases as well. So yes, all good, perfect. So we got 71 milliseconds with respect to runtime, and I think I implemented it previously and got a bit faster, I think, but not so. Yeah, so 140 milliseconds giving 91%, but those just milliseconds, as you can see. So let's go to description, erase it, and yeah, so fantastic. It worked as expected. So now a approaching problem from a different angle. So often it's good to know and might be quite creative. So this time, let's visualize the plank as if it's collapsing from both ends. So imagine the ants are stationary and the plank ends are moving toward them. So we are reversing basically the task. So the process will be as follows. So if we have an ant moving left at position 3, the left end of the plank would hit the ant in 3 seconds, right? And for ant moving right at position 2 on a 10 unit plank, the right end would take exactly 10 minus 2, 8 seconds to hit the ant. So with this, the problem becomes a game of finding out which ants get hit last by collapsing a plank. So let's implement it as well. So left time will be position 4, position in left, and right time will be n minus position 4, position in right, and return max left time plus right time. So this is a bit different approach, but let's see if it's working. So I'm running it and yeah, all good. So let's submit it also for unseen test cases. So for unseen test cases, as you can see, it's a bit slower. So it took 166 milliseconds. I think I implemented it previously and it was also a bit faster, but yeah. So basically, it's alternative solution, runtime 154 milliseconds. So let's wrap up our session today. So we look at an interesting problem, broke it down and solve it with two a bit different approach. And yeah, if you want to see implementation in other languages like Rust, C++, Go, and much more, I will provide a link in the description below, so you can know better other implementation if you prefer languages like Python other than Python. I really like Rust and as well Go. So yeah, remember, coding challenges are all about finding pattern and basically simplifying complex problem, and keep practicing, and soon enough you will start seeing patterns everywhere. So if you found this session helpful, don't forget to hit the like button, share, and subscribe for more coding adventure. And if you have any question, drop them in the comment section below. And as always, stay motivated and happy coding!